Right. So the next thing we're going to take a look at, after we just looked at just sort of a global view of the periodic table, is now some specific regions of the table and how we refer to these regions. So we talked about the table being arranged in order of increasing atomic number. Why is it that you couldn't just list them out left to right from 1 to 118? Why does it, come back? It goes from 1 to 2, then it goes back 3, 4, all the way to 10, and it starts back to the left side, 11. Well, that is the whole nature of the periodic name and periodic table, and that is when it's arranged in this particular manner, what we see is that the properties of the elements and are arranged this way repeat in a periodic pattern. So as an analogy to it, you can probably think of, if you're familiar with the piano, for instance, you think about the scales on the piano, they repeat as you go down the keyboard from left to right, right? The same notes repeat themselves, just at a higher octave, for instance. But it's the same idea. As we go down the periodic table from left to right, the patterns or the properties of the elements repeat in a periodic pattern that is predictable. Okay, and that is another key feature of the periodic table. Just based on where something is on the table, you can actually predict some of its characteristics, both chemical characteristics as well as some physical characteristics as well. So it's a very, very important feature of the table is that its predictability based on where things are. Now, let's take a look at how we assign or how we refer to different regions of the periodic table. So the first thing to take a look at are things called groups. So a group on the periodic table is nothing more than a column, uh, a vertical column that we're looking at. So it goes top to bottom. Sometimes these are called families. The reason is because the members of the same group or the same family are going to have similar characteristics. So elements, let's say elements in the same group. Have similar features, similar characteristics, similar properties. So for example, if you look at helium over here, well, in the same group or the same polymer of helium, there's neon, argon, and krypton. So we can say, just based on that general trend, that these should all have similar characteristics to each other, right? They belong to the same group. So we can number the groups as follows. So the first group here on the left side, this is called group 1A. The second one right next to it is called 2A. And if we jump all the way over to the other side here, where boron is, this is 3A, 4A, 5A with nitrogen, 6A, 7A with fluorine, and then 8A with helium. So that's how we're going to number the group. Okay, so the group numbers with the A notation. So as we talked about before, argon down here, that belongs to the group 8A elements. And it should have a similar characteristic, similar properties as any of the other elements in group 8A. So those are groups. The other feature of the characteristic of the periodic table are things called periods. In the periods of a horizontal row, and these go from left to right. So I'll do that in a different color in green. This is period 1. This is period 2, period 3, period 4, 5, 6, 7. The period 1 goes all the way across hydrogen, all the way over to helium. That's the first period. Period 2, lithium, beryllium, all the way over to neon. Period 3, sodium, magnesium, all the way over to argon, etc. So when you think about it, right, we can use the period number and the group number as sort of a locator for the elements on the periodic table. And by the way, I'll abbreviate periodic table as so. For example, if I ask you what is the element that is found in period 4, group 7, right? So we find period 4 over here. Left side go all the way across. And then group 7 up here, we go all the way down. Where do they intersect? They intersect at BR, which is bromine. Okay, you can think of them as sort of latitude and longitude on the periodic table or GPS coordinates, however you want to slice it. There are ways to identify where something is on the periodic table: group number and the period number. Now, there are certain collective names that we give to different to some of the groups and also to different other regions of the periodic table. The first collective name we're going to take a look at are the names given collectively to groups 1A and 2A, the ones in pink that I'm highlighting, and then groups 3A through 8A. All of these, so there's the 2 columns on the left side, and then the 6 columns on the right, we refer to those as a representative element. So the things in pink here, we call these representative, or sometimes they're called the main group element. And the reason is the majority of the elements that we're going to come across belongs to those groups, the 2 left columns, the 6 columns on the right. And we can use those elements to come up with different trends to generalize about the properties of the periodic table, right? So when we look at trends in the periodic table, those are the elements that we're looking at that belong to the representative or the main group elements. Now, within the representative elements, we have group numbers that themselves have specific names that are associated with that. So let's take a look at a few of these. So group 1A, these are called the alkali. Okay, so for example, if I ask you, what's an alkali metal in period 5? Well, alkali metal is group 1. Goes here, and in period 5 would be this period, so that's the rubidium RB. The group 2A are known as the alkaline earth metals. So those are things like beryllium, magnesium, calcium, strontium, barium, radium. And if we jump all the way to the right side, we have group 8A. These are known as the noble, or sometimes they're called inert gases. Okay, and inert here means unreactive, so we really don't react very easily with other things. So things like helium, neon, argon, krypton, xenon, radon, and so on. And then group 7A, the one that's next to them, those are collectively known as halogens or halogens that way. And the word halogen here means salt, halo, and then gen means gen. So when these elements combine with other things, they usually so you need to know the collective names for these, which is 4 groups: 1A, 2A, 8A, and 7A. Now, as we've gone through and identified these different groups, different regions, you will notice that there are 2 big spaces here that we didn't quite color code. So let's address those right now. The area in green, that big area in the middle of the periodic table, that is collectively itself known as the transition elements. That do the transition elements. All of them are metals that you find in there. So they're also known as the transition metals. And there really isn't, not going to worry too much about identifying sort of the column numbers for these, right? They tend to behave a little bit differently and not as predictable as the main group elements. So that's how we kind of lump them together. And then the two rows underneath that seem to really not belong in there, you can see though that they're connected to um, via the dotted lines to period 6 and 7. And if you note, if you look closely here, you will see that the atomic numbers jump from 56 in barium all the way to 72. Well, where's 57 through 70? Well, it's here. And the reason why we put them underneath is if you were to stick them in there, the periodic table would become a little too broad and a little too cumbersome to work with. So where those two rows actually belong would be inside of the transition elements. So those two rows collectively are known as inner transition elements. Think of it. Highlight these in yellow, and then that would be the inner transition. So we have all of the regions of the periodic table identified now from the main group elements, the two columns on the left, the 6 columns on the right. We have the transition elements in the middle, this green portion. We have the inner transition elements in yellow. And then we have the collective names given to the group 1, alkali metals, group 2, alkaline earth metals, and then group 7A, the halogens, group 8A, the noble or the inert gases.